All right, so here we go, the last exercise for the chapter. So I know that some of you already had a discussion with me about the Caesar cipher, and I think if you've been going to the hacker problems that Mike does out in the main room during studio time, then you've probably already had a look at the Caesar cipher, and maybe even the harder, more complicated Vigenère cipher. If that's the case, then this exercise will be super easy for you. If not, then it's going to be a little bit hard. So when we talk about the Caesar cipher, what we mean is when you take a number and move every character in your message that many characters to its right, quote unquote, in the alphabet. So for rote 13, it's a very specific version of that where all it does is just rotate every character by 13 characters. So for example, as I say here, A becomes A 13 spaces over, which in the alphabet is N. And we can show that here. If I paste in my alphabet that I already copied, you can see that A, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 becomes N. So if A is index 0, then N is index 13, so 0 plus 13 equals N. Same for B. B is index 1. B plus 13 equals 14, so that would be O. So that's all rote 13 does. So it's, in a lot of ways, pretty similar to what we just did with our substitution ciphers. We're going to need this alphabet that we've written. We're going to need to take the index of the alphabet for each character, and then we need to essentially take its index through a rotation. So I will say that the easiest way to handle this, if you think about it in comparison to what we did before, if you want to rotate things 13, it's very simple to rotate something like A, which just becomes N. But if you wanted to rotate something like S, what do? Well, you need to rotate it 13 times, right? So S becomes 1, 2, 3, 4, 5, 6, 7, and then you run out of spaces to rotate it, which means you have to start over from the beginning. So 7, 8, 9, 10, 11, 12, 13. So that would change it into F. So instead of being index, let's see, what is that? 1, 2, 3, 4, 5. So instead of being index 18, which is what S usually is, it needs to become index 5 by adding 13. So if you think about how we would need to do that, where we have a lower limit and an upper limit, and when we add things, it needs to roll over to the lower limit. We've done that stuff before, and it's going to be a case where we need to use the modulo operator. Okay, so I'm going to get started on this. As I'm working on it, feel free to pause anytime to try to jump ahead and try to figure out the next steps on your own. Okay, so I'm going to create a return string that is an empty string, because I'm going to need to use the accumulator pattern in order to do this. And then I'm going to run through my message, so for car in mess, because that's what they called their message variable. So for chair car character in mess, if char is not in alphabet. So if the character is not an alphabetical character, then you need to have the return string plus equals that character. So that takes care of punctuation, spaces, and all that stuff. Otherwise, what I need to do is find the index that I need to go to. So I need to first find the index of the character that I'm currently on. So alphabet.index, what would it be? Alphabet index chair. We could also do find chair. It's the same thing. Index works the same, except you only want to use index when you know what you are looking for is going to be in the string. So I wouldn't do this if I didn't know that it was going to be if I knew it had the possibility of not being in the string, right? But I know that char is going to be in alphabet because I already tested that up here. So I can use index just fine. So alphabet.index char is going to give me the index number in the alphabet. So again, B equals 1, F equals 8, etc. of the character that I'm looking at. And then I'm going to want to rotate it 13 places. All right? So I'm going to call that new index, new IDX, is going to be alphabet index of the character plus 13. So that's going to be where I want to end up. So this is easy enough. If I'm rotating A plus 13 equals 13, so it's just going to give me N as my new index if I use new IDX as my index. So in this case, alphabet new IDX will simply return index. Will simply return rather N very easily. So I can just do that. I can have return string plus equal alphabet new IDX. But that's not going to work. That's going to fail because if as I said earlier, if my index is already more than 13, so for example, if anything in or higher, so in rotated 13 becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then back to 1, or back to 0 rather, 13. N becomes A. So anything higher than N is going to need to roll over to A. So how can we test to see whether or not we need to roll over? Well, we know we need to roll over if our index that we got to is higher than 26. So if new IDX is bigger than 26, which is the highest index that we can represent, then we need to make it so where we take the modulo value of our new index. So new IDX equals new IDX modulo 26, and then our return string gets added to by our new IDX. So what this is doing is it is moduloing the new IDX by 26. So for example, in the case of N, if we wanted to rotate N13, N's alphabetical index here is going to be 13. And 13 by 13, oops, sorry, getting a phone call. 13 plus 13 is equal to 26, which is going to be outside of our index. Oops, I just realized this should be 25, not 26. This is going to be outside of the index because it's over 25, which I just realized should be actually my upper limit because the index on Z is 25, not 26. So N is 13 plus 13 equals 26, which means that if I try to index into alphabet index of 26, I get garbage data. It'll return an index error. So if I take 26 and modulo it by 26, I get 0, which is the index of A. Same thing for if I do O. O is 14 plus 13 is 27. 27 modulo 26 is 1, which means B. So all I'm doing is moduloing that, saving that into the new index variable, and then getting the same thing as I did down below here. Now, I'm going to have to put this into an else statement so that it doesn't run twice. That would be a very weird error. And then I need to, outside of my for loop here, return my return string. Alright, here we go. Give it a test. Save it. And run it. And we have an error. Bad input on line 14, which means that I forgot to... Nope. Made a typo. There we go. Save it. And run it. Alright, so rote 13 equals NOPQR. Rote 13 NOPQR equals ABCDE. this sentence, rote 13 is symmetric, you should see this message. So we rotated it twice, meaning we rotated it once by rote 13 and then rotated it again by rote 13. And because rote 13 is symmetric, meaning that if you rotate something that's been rotated already, it goes back to where it was, we get, since rote 13 is symmetric, you should see this message. So it worked. That is it. That is the rote 13 implementation of the Caesar cipher. Now, if we wanted to make a general Caesar cipher, as you're going to have to do for a later assignment in this class, all we would need to do, honestly, is make a couple of real easy changes. But I'm not going to do that because it is an assignment later, and that would be giving you the answer. But since you've already done a rote 13 function, when you get to the Caesar assignment, you'll want to come back here and check out what you did, because it's going to be pretty close to what you'll need to do for the final Caesar assignment. While I'm here, let me take a look at the weekly graded assignment real quick and see if there's anything I want to say about it to you guys. It says to write a function to analyze text that receives string as input. Your function should count the number of alphabetical characters A through Z, or A through Z, capitalized, in the text, and also keep track of how many are the letter E, upper or lowercase. Your function should return an analysis of the text in the form of a string phrase exactly like this. This text contains 240 alphabetical characters, of which 105, 43.75%, are E. You will need to make use of the isAlpha function, which can be used like this. It's a method on a string, so A isAlpha returns true, 3 isAlpha returns false, and isAlpha returns false, space isAlpha returns false. And you can also use it on variables, so if you set myString equal to Q, then myString dot isAlpha returns true. So you've got some tests here for that. I will say it is going to be not as hard as some of the exercises that we've been through already in this chapter. Think about what we've done. Think about how you would count characters as you go through a string. Think about how you would count how many of those characters are E's. Go through and figure that out. Remember that your return string that you need to return needs to be exactly this. So you should return a string at the end of your function that will return a value that looks like this. So you can do that through some weird concatenation stuff, or if you're feeling like you want to do it as a challenge, so to speak, you can try to use the format function, the dot format function, and you can find that described back in the earlier chapter. So go check that out and see if you can use that for your final version of this. And good luck.